Alright, so if you're watching my videos, I'm using arcsine and arctangent somewhat interchangeably. They create the same number, but like if I program it, it's gotta obviously always be the same. But my definition, as I said before, is the infinite prime number exists where the arctangent of the prime number over the previous prime number minus 1 over infinity equals the same number as arctangent 45 degrees over 45 degrees minus 1 over infinity, which is only possible at infinity. So infinity is prime by this definition, but then infinity minus 1 is equal to or greater than p infinity minus 1, or the previous prime number to infinity times 2, because infinity minus 1 must be factorable by at least 2. This makes sense mathematically, but it doesn't give us real numbers to work with necessarily. But what it does mean is when you look at this graph and these different, so at the 45 degree lines, those are a different number of steps back from a prime times a prime. So they have a different sine or tangent that we're turning into an angle. And as they go, that angle approaches 45 degrees, right? So if we can agree that there's a maximum that they can verge on being just off of 45 degrees, because if they were 45 degrees, then they'd be equal to themselves. Then we can create signal processing using this to say that we know what the sine relationship is here, and we know its growth rates, and so then we can figure out where they agree that primes are going to exist out to some limit where the resolution is too fine. But then we'll have a whole new set of primes that we can zoom out and do the same exact process with, and you can use farther steps back to narrow down the signal, and then your small steps to confirm your signal, and bam, within a couple of signal processing geometric steps, you can find prime numbers. I'm not actually there. That's my theory.